All right, stats, here we are for your video for Monday, September 11th. All right, make sure you pay great attention at the end for a special announcements. Okay, so this is in your Chapter 3 notes packet. This is page 13. This is where we left off on Friday. We were talking about, was this Chevy cars, or no, cars in general, and the 25th and the 70, or like the first quartile and then the third one. So this 25th percentile, 75th percentile. All right. So that's an area of 2500. That's an area of 7500. You can look both of them up. Again, you go to the Z table and you look in here where the area is. I left my Z table at school. So you can also Google if you ever are at home and forget when, you can Google Z table PDF. You just find one there. Anyway, they're going to be opposite Z scores because these two proportions, areas, add to 1. So 0.67, negative 0.67. So you're looking for what average gas mileage would be at the 25th percentile and then the 75th. So the middle, 50%. So you set for the 25th, negative 0.67 equals x minus the mean or the standard deviation. Remember, you cross multiply here. And then 0.67 equals x minus the mean over the standard deviation. Cross multiply here. Add 18.7 over to both. So quartile 1, 15.8 miles a gallon. Goodness. And quartile 3, still only 21.58 miles a gallon. All right. So now we're on page 14. And that is the last full, that's the full page we're going to do today. So page 14 in your note packet, flip it over. We're going to look at 339. It says, what's your percentile? It says, reports on a student's ACT or SAT usually give the percentile as well as the actual score. The percentile is just the cumulative proportion stated as a percent. The percent of all scores that were lower than this one. In 2007, composite ACT scores, the distribution of, I'm sorry. Wrong one. We're close to normal with a mean of 21.2 and a standard deviation of 5. So X's 2007 ACT scores, they're approximately normal. Mean of 21.2, standard deviation of 5. Jacob scored a 16. What percentile is he? So Z is 16 minus 21.2 over 5. That's his Z score. That area, when you look it up, is 1492, and that area is the percentile. So the Z table does give you, what is, as they say here, the cumulative proportion. Okay, so 14.92 percentile is what you'll say for me. The report's probably going to state that he is in the 15th percentile. Okay, then we got 340 here. Now, this one was with SAT scores. This is pretty interesting. I didn't know this before teaching this class. It is possible to score above a 1600 on the SAT, evidently. Now, this was, in a later version, or early version. But scores 1600 and above are reported as 1600. In 2007, the distribution of SAT scores, combining math and reading, was close to normal with a mean of 1021 and a standard deviation of 211. What proportion of 2007 SAT scores were reported as 1600? I don't know if that's the case now, that can happen. But 2007, it was. Okay, so X is 2007 SAT scores, and they were close to normal with that mean, that standard deviation. So that's why we could say what's the probability that X is greater than or equal to 1600. So first off, yeah, okay, here's... That's at the end. So got to find the Z-score, 1600 minus the mean over the standard deviation. You get a Z-score of 2.74. When you look on the Z table, 2.7, go over to 4, you get 9969. But we want greater than or equal to, so we got to find the complement. We got to do 1 minus that. So that is a very in it wanted proportion. So that would be our answer. That's 0.3%. That is very, very low. Okay, very, very rare. That's 3 out of 1,000. All right, I accidentally went out of order here. So 41 we're going to do first. Again, if you got to pause this, should have said this earlier, but if you need to pause this whenever you should write down what I have written down. Okay, so if you need to go back and pause this, that's fine. I hopefully I'm going to talk a little bit here so you can write this down, and hopefully give you enough time to write down what you need. So what percent of young women are taller than the mean height of men? So I went out of order here. The heights of women aged 20 to 29 follow approximately the normal distribution, 64, 2.7. Men the same age have heights distributed as normal, 69.3, 2.8. What percent of young women are taller than the mean height of young men? So X is a height of a woman. So what's the probability that X is greater than or equal to 69.3? Now remember, X is a height of a woman, so woman's mean is that, the standard deviation is that. We just got to be careful there, because I know we're using the mean height of a man right there. Okay, so we get 1.96, which is going to be a very famous C-score for us later this year. Area associated with that is 9750. Go down to 1.9 over to 6, you get 9750. Now I want greater than or equal to, so I got to do 1 minus that area, and that's the proportion. That's 2.5%. That's right at the cusp of an outlier. All right, it's a tall outlier. 2.5%. All right, so pause this, write all this down if you need to. I'm going to go up to 242. 242 gives the same background information, only it wants to know what percent of young men are shorter than the mean heights of young women? Okay, so that's just a fact for both, but X is gonna be the heights of men here. It's approximately normal, 69.3, 2.8. What percent of young men are shorter than the mean height of young women? So the probability that X is less than or equal to 64. Again, we're using the male mean and standard deviation. We get negative 1.89. That area associated with that, when I look at on the negative side, negative 1.8, all the way over to 9 is 0.294. Now, I want less than or equal to, so I'm going to keep 0.294. That's 2.94%. 2.94%. So it's almost an outlier. All right. Then we just have 2 more here, and then a little special announcement, special deal. All right. Let's take a look at 343. All right, so 343, changing the mean and standard deviation of a normal distribution by a moderate amount can greatly change the percent of observation in the tails. Suppose that a college is looking for applicants with SAT math scores 750 and above. Whoa. 2007, the scores of men on the math SAT followed the normal distribution with a mean of 533, standard deviation of 116. What percent of men scored 750 or higher? I know there's some light issue right there. All right, so X is a men math SAT scores 2007, so it's approximately normal. That means that's standard deviation. What's the probability that X is greater than or equal to 750? Z, 750 minus the mean or the standard deviation. And you know, that's a no, that's not good. I shouldn't do that. That is 217 over 116. We need to do that first. 217 over 116. All right. I got 1.87 when you look that up. Get 96.93 for the area. This is greater than or equal to, so I got to do 1 minus that. I got to do 1 minus that. All right. 0307, that's 3.07%. So roughly 3% of all men who took this would be able to hit that standard. All right. So then it says women's SAT scores that year had the normal 499, 110 distribution. What percent of women scored 750 or better? You see that the percent of men above 750 is almost 3 times the percent of women with such a score. Why this is true is controversial. On the other hand, women score higher than men on the new SAT writing test, although by a smaller amount. All right, so This time X is a woman math SAT scores in 2007, and it's approximately normal with a mean of 499, standard deviation 110. I want to know the probability that X is greater than or equal to 750. All this I want to see in your homework. All this I want to see on the quiz. So Z is 750 minus 499 over 110. 251 over 110. Z scored 2.28. When you look that up, you get 98.87. This is a greater than or equal to, so you're going to do 1 minus 98.87. You get 0.113. Multiply that by 100, that's 1.13%. 1.13%. All right. Now our last example, again, you'll have time to do one last thing here. Sun's coming. All right. So, grading managers. Some companies grade on a bell curve to compare the performance of their managers and professional workers. This forces the use of some low performance ratings so that not all workers are listed as above average. Ford Motor Company's performance management process for a time assigned 10% A grades, 80% B grades, and 10% C grades to the company's managers. Suppose that Ford's performance scores really are normally distributed. This year, managers with scores less than 25, that's 10% of them, 10th percentile, X is 25, received C's, and those with scores 750 and above received A's. That's the top 10%, that's the 90th percentile. What are the mean and the standard deviation of the scores? Okay, so here's where we're going. Starting at the bottom 10th percentile and down, that's C, so you look up 0.1000, that's a Z-score of negative 1.28. 90th percentile is an area of 0.9000. That's a Z-score of 1.28. All right. So what are the mean and the standard deviation? Whoa. Now, those scores are X values. So just like we did on one of the earlier ones, was at 337, the first one today, we're going to say this Z-score is equal to, this time it's 25 minus the mean over the standard deviation. That's for the C's. Now for the A's, it's going to be 1.28 is equal to 475 minus the mean over the standard deviation. Okay, so we're going to do a little cross multiplying. Then we get these two. Negative 1.28 standard deviation is 25 minus the mean. 1.28 standard deviation is equal to 475 minus the mean. These are opposites, so we're going to stack them together like this, and then we're going to add them up, because then, just like in college algebra, we can solve a little system here, huh? We're gonna add these together. We get 0 is equal to 500 minus twice the mean. That means twice the mean's 500. The mean is 250. We have found the mean. So I'm just going to use this right here. It's got a positive. So that means 1.28 is equal to 475 minus 250. That's the mean over the standard deviation. I'm going to cross multiply here. 1.28 times the standard deviation, which honestly, I could have just plugged it in right here. That would have been quicker. You guys see that? That's funny. I was not thinking when I read this. You could have just plugged 250 in for the mean right there. And then we get this. Divide by 1.28, and the standard deviation is 175.78. Okay. Now with that in mind, folks, get out a separate sheet of paper. Be quiet about this. Do this quietly. Get out a separate sheet of paper that you're going to write your name on at the top. Unfortunately, last year in college algebra, all of us in this room did not do a good job reading my emails when I was gone or watching videos when I was gone. And unfortunately, I'm not led to believe that that has improved. So, I've not done this before, but this is going to be to drive home a point. Okay, so this is for 5 actual points. For 5 actual points, you're going to write all the work on a separate sheet of paper and make sure your name is on it. Okay, so it's just going to be one sheet of paper, front side. And you're going to turn this in during the last 2 minutes directly to Mrs. Lavoie. All right, and And if not many other people or other people are unfollowing you doing this and they're watching something else, you know what? That's their loss. You do not need to tell them. Okay, this needs to be turned in during class. If it's turned in later in the day, then I know you didn't watch this, and you know we're gonna have to have a difficult discussion about whether we should be taking this class. All right, so again, I hope it'd be great to be proved wrong here and that you all watch this, and I have these all turned in tomorrow during class. All right, here's the question. So that's what we're gonna do. You're just gonna write question. Scores on a certain test are approximately normal. So approximately normal with a mean of 150 and a standard deviation of 18. Let X equal an individual student's score. So that's what X is. And it says here, what is the probability a student, and write everything down here. Write everything down here. What is the probability a student scores a 650 or above? Or 160 or above, goodness. That's probability X greater than or equal to 160. There's my z-score calculation. Get a z-score of 0.56, remember round up. That area that corresponds to just 7123. 1 minus 7123. You get 2877. Why did I do 1 minus? Because again, we're looking for greater than or equal to. We're looking to the right, got to find the complement. And lastly, here we go. What is the probability a student scores a 130 or below? What's the probability that X is less than or equal to 130? The z-score for that is z equals 130 minus 150 over 18. Which is a negative 20 over 18, which is a negative 1.11. The area that corresponds to that is 1335. And I want that. It's less than or equal to, I want that, 1335. Again, keep this to yourself. Just hold on to this. And the last 2 minutes, turn this in directly to Mrs. Lavoie. She knows what's coming. And hopefully I got them all. Or, you know, if someone was absent, you then get this to me in the morning, all right, before class, all right, because then you've watched this video, all right, so that's it. I need them either during class if you're here. If you were here and you turn it in later the day, you're not going to get much credit because you didn't do it when you're supposed to. And if you were absent on Monday, like I am, then I want to see this before school, unless you're a late arrival. All right, then turn this in when you get there. All right, anyway, this is Yak Math Video signing out.